Good evening. Yes, I was born in Italy, and then 20 years ago I moved to Amsterdam, to the Netherlands. So I have this kind of split thing. I don't really know if I should say I'm Italian or Dutch. According to my passport, it's Dutch, but according to my culture, I'm more Italian, I guess. And I've worked then for almost 20 years in the field of science communication, mostly with science centers and museums. So that's a kind of my background. And I do, however, for museums, I don't do exhibitions, but I worked on collaborative projects looking at innovation and art and science. So a bit, indeed, of the innovative aspect of science centers and museums, and also in general of science communication. So today, actually, the title of this talk was From Citizen Science to Scientific Citizenship, because there's actually two things that we'll explore today. But then, when I was reflecting on the things to say, and also with some conversation with Dimitri, I realized that what I would really like to convey and hopefully also get some questions at the end is really why science communication matters to science itself, because many times when we talk about science engagement, we always talk about the public and things about the public, and we kind of forget that it should be a relevant and important activity for scientists and researchers themselves. And because it is such a new endeavor, a new development, it's not always very clear what this relevance for science is. So maybe, I'm not going to give you the answer at the end of this lecture, but maybe through this and with your thinking, then we get closer to always remember how important science communication should be for science itself. So let me start with just a few examples of, let's see, maybe, can we turn down the lights a little bit, or can you see clearly on the slides? Yeah. A few examples of what is called citizen science. Have you heard about the term? Raise your hands, the ones who heard about it. Okay, excellent. So citizen science is the kind of things that I'm going to show you in the next 5 minutes. It is basically when ordinary people participate in a research activity in different ways, by collecting data, by thinking about the research, by working together with a scientist, but without a specific role, just because they are interested, because they are citizens, and that's why it's called citizen science. But more importantly, it is a way for scientists also to understand what is really important for the citizens, because many of the ideas come from the citizens themselves. So this is an example. This is an iPhone, which you probably know, and the iPhone can have a little device, which is this little thing here, which indeed is a small little piece of plastic that costs 70 rubles. And you can get it from, you can order by mail, and it contains a little polarized filter. You put it on the camera of the iPhone, and you get an image which is a photograph of the sky, and because of this polarization, it allows you to basically to understand if there are particles of dust or pollution in the atmosphere. In the Netherlands, a university started this project, and thousands and thousands of people participated making these observations. And this is indeed just an example of how many people participated. The great thing is that normally to measure the quality of the air, there are a few instruments, put in certain locations in the country. But who decides in which locations these things are put? And how many are there? Not so many. So what it turns out is that, for instance, there are large parts of the country where there is no measurement of the quality of the air. With initiatives like this one and several others, you have a much more detailed map of the quality of the air because people participate. And without the participation of the citizens, you would never have this. So this is just an example. These are the maps above that came out of this experiment, and they are much more detailed than the maps that are done with conventional items. You can see that the level of detail here is much less detailed as that one. It's like, you know, big pixels. Another example is this. This is a kit that you can also order online. It costs probably about $10 and is a way to measure earthquakes, so movements of the earth. And again, this is a terrific way to get measurements of seismic activity in places where nobody else can measure that, because you can, you know, several people can order this, they can put it in their buildings, in their schools, in their places, and collect all this information. You get indeed a level of detail. And also it comes because, as you know, earthquakes are not dangerous by themselves. They are dangerous because of the buildings that are built. And usually they are not built according to the safety standards. So it's very important to measure wherever people are, what is the level of seismic activity. And this is kind of put that power into the hands of citizens. Another example, this is called Safecast. You remember a few years ago there was an accident in a nuclear facility in Japan, in Fukushima? Well, there were some people in the States that had family living there, and they couldn't have access to their family. They didn't know what was going on. They started, and because they were knowledgeable with technology, they invented basically also a way to measure nuclear, well, not nuclear activity, the radioactivity, and they sent the instructions to their families in Japan. They built these kits because, you know, it's really stuff that you can buy and you can access very quickly. And they immediately made a map of the radioactivity that was extremely detailed and much faster than any other activity, than any other map done by government sources. This is a video game. It's called Fold It. You can go online and play with it. And it's a video game that uses molecules and molecular structure to play, and you can compete with other people, and you can make scores and win against others. And the thing is, it's built on molecular structures that actually scientists are having difficulty to understand. So by engaging all these gamers, people who like to play games in this, they discover stuff that the scientists could not discover. And just 2 years ago, I think, through this game, one molecule which is fundamental for understanding how the HIV virus works was discovered using this game. So these are all examples, or there is another one actually. It's called iWire, and iWire is similar, but it looks at neurons. So you can scan neurons and on your computer, and by playing the game, actually you can create all the connections that scientists need in order to understand how these cells work. So these are all examples of actual research science that is done by ordinary people, because anybody can go on iWire and start playing the game. And you can order the kit, and you can actually, if people are a bit confident and competent with technology, they can develop kits that measure the seismic activity or radioactivity or the quality of the air and so on. And just to show you how big this thing is becoming, I have a video now, a short video, that is actually produced by Apple, that has produced the iPhone, that shows how they do citizen science. And The reason I'm showing is that if a big company like Apple and Google and Samsung are doing the same, are doing this, it means that it's going to be big.
I've spent a large part of my career focused on a number of different diseases, from obesity, diabetes, heart disease, Alzheimer's, and one of the problems has really been around our ability to understand what's actually going on in those diseases.
The key to understanding health and disease is research and data.
What all researchers want is measured, quantitative, objective data.
Well, up until now, when somebody wanted to do a research study, they might, put up a bunch of flyers around and hope somebody comes along and tears off the phone number. Methods for conducting medical research haven't really changed in decades.
We have sent out over 60,000 letters. Those 60,000 letters have netted 305 women.
We really do need to transform how we do research, and the iPhone, with an ability to collect data, could be a powerful tool for research.
Research Kit is a framework. It's a framework that enables medical researchers to more easily design the apps that they're going to use for clinical studies.
We're talking about trying to change the scale of the amount of data that you can collect. Going from data that might be collected, say, once every 3 months, to data that's collected, say, once every second.
The iPhone's being carried now by millions of people all over the world. So to think that this device that you use to check your mail or Facebook can be used to battle disease is really simply amazing.
The concept that I could kick out a survey to patients every day, every week, that would show up on their phone and would actually improve their health and our ability to care for them. That's a game changer. That is awesome.
We can now engage unprecedented numbers of individuals in large geographic areas, many of which have never been able to participate in research.
Half of the Parkinson patients in the world is in China. China has the largest number of mobile phone users, which means that we can collect more information so that can give us more accurate estimate on things for the research purpose.
What we're building into this platform are simple structured tests that people can go through, things like tapping or a voice test. And this can all be done using the built-in sensors on the device and a little bit of code.
One of the things that Research Kit will do is put people at the center of research, giving people the insights and the tools they need to live better and healthier lives.
It's going to change research for every condition that's out there, and that just makes it very accessible to patients. The easier you can make it for people to participate, the better off you're going to be.
I want to leave a legacy for my granddaughter. Maybe when she's 25, they'll come up with, oh wow, that research study that was done in 2015, with the iPhone was really key in making a breakthrough on how we can better help asthmatics. She'll say, wow, my grandma was a part of that.
Putting the solutions in the hands, literally the hand with an iPhone of the patient, this is the answer. This is exactly where medicine is going. It has to. It has to.
So, you see, if big companies are behind this, it means really that it's going to be okay. It's going to be really great, and indeed, it is changing the way research is done. Finally, these pills are antibiotics. There is a big problem at the moment that more and more bacteria are becoming resistant to antibiotics. So all this stuff is going to be useless with catastrophic consequences, some people think. Well, an Indian student studying in London had an idea. In nature, actually, there are a lot of antibiotics. They grow literally in the gardens. So he said, but of course it's very difficult to exploit them because you have to search for them, you have to test them, and of course a lot of them are already discovered. So it is, for the traditional way of finding this stuff is not very practical. So he had an idea to make a kit that is very simple to produce and that can be sent around, and basically allows anybody to get a sample from the ground, test it, and see if it contains antibiotics, and then collect these results and hopefully find indeed new antibiotics. It's a kind of initiative that came just out of indeed his observation. So these examples are just, you know, a quick way to show you how science now more and more is done in a way that we can describe as participatory, because it involves several actors, several people with different roles, and sometimes roles that are not defined from above. You know, the Indian student working at in the design school that invented the kit to find antibiotics, you know, he is not a researcher, he's a designer. And you know, what do designers have to do with science? Well, a lot actually. So it is indeed, science is becoming participatory. These are also all activities that are bottom up. They come up from the ground, literally from the needs of people rather than from above. So it is a way really from starting from what are the needs, the necessity, the questions that people have. You know, it is the scientist that was worried for his family in Japan that made and that led to that system called Safecast. So it really comes from the bottom up. And also are all activities that happen on the fringe of the traditional scientific institutions. This is not stuff that happens in the university or in the research center. It happens literally on the border. It touches the university, but it's also done together with industries, with mobile phone producers, with patients associations, and so forth. So indeed, it's a very it's really a new understanding of how science is taking shape. And we can see that actually because if you want, and very, very simplifying very, very much, in the last century there have been, you know, moments that have completely redefined the role of science in society. First was the discovery of the atom, and of course all the quantum theory that completely revolutionized what was known before. The first atomic bomb that had, you know, immense consequences on reflecting on the role of science and the purpose of science in society. Sputnik that went to space and started, you know, a whole new race to engage people in the fascination for science. And of course then also the first man on the moon. These are all things that played an immense role in shaping the role of society, of science in society, and the meaning really of science in society. All this is to say that there are, and I mentioned here, four qualities or four aspects of science that are defining the current way to communicate science with the public and to engage the public. The first is science is diffused, so it is not anymore in the building of the research center. It happens anywhere. Everything that we touch and we do there is a lot of science and technology behind it. Also, science is more and more applied. The science happens mostly also because it's driven by needs or by because it's exploited for the use. The example there actually is a very interesting one. It comes from a group of students in France that realized that bacteria can also make light, as maybe you know, sometimes also in the water you find bacteria. And they said, well, why don't we exploit that to make light that can be used in as natural light? And so they have a company now that produces stickers that you can use to make windows of shops, for instance, that work with bacteria. And that is indeed, there is a lot of science there, but they see themselves as a company producing light. Science is more and more interdisciplinary, so that's one of the keywords of today. There is literally no field of science that is still confined in itself. And also, science is more and more reflexive, meaning that scientists themselves are asked actually to reflect on what they do in order to be in sync with society, in order to understand. And I'll come back to this concept in a moment with an example. So, but it's really the fact that scientists cannot just proceed on a straight line in a linear way. They have to come back and think about what they did, both in terms of the responsibility for society, but also because science and innovation is not really a linear process. Sometimes you have to really come back and question all the assumptions that you made at the beginning. And this process of reflexivity, indeed, is something that involves also different members of society. That picture there comes from a science center, actually science, it's called the Science Gallery. It's a place in Dublin where it is half art gallery and half science place, and it's part of the University of Dublin, of Trinity College in Dublin. And what they do is they create a lot of exhibitions where they use both the artistic research and the scientific one to question what science means. And this specific piece, for instance, was an artist that made those kind of masks, that on the right, made of the DNA that she extracted from cigarettes that were left on the street. And basically, by analyzing the DNA, this is not yet totally feasible. There is a little bit of science fiction in this, but the fact is that by analyzing the DNA that people leave behind with indeed the cigarette, with hair, with whatever you touch, it is possible to analyze the differences between DNA. And by that, the step actually, she says, is not that far from the moment where we can actually build even images of people like that. And the value of this work is actually to show that if, say, in 5 or 10 years we can really do this, what do we need to do now in order to understand that we are actually leaving behind us a trace of everything we are? So in that sense, science engagement helps the scientists to reflect about their work, because it helps also them to imagine the future that they are going into. So the question is, where is the public in all this? And also it is, I hope, a little bit clear that because of the way science is done today, you cannot ignore the public. And actually, more than the public, there are several different publics, and the public is actually a fundamental component of the way of doing science today. Now, there are different ways to understand what is the relationship between science and the public, and you probably heard about different models of science communication. You have the deficit model. You have the dialogue model. You have the participation model. And there is a fourth thing which I will come back to today, which is the concept of responsibility. And responsibility basically means that all the actors, all the players, all the people actually that are involved in the scientific process are responsible in their own way for the results of this process. And in that sense, it is it's not a model yet, but it's something that comprises all the other models above, because it puts also back the accent on what is the value for scientist of doing communication with the public. And the way to understand this really is to always question, in whatever kind of public engagement, public communication activity, is always ask, what is the value for the ones who organize the activity? Of course, we know that it's good for the public, and it could be from writing a press release to organize to doing a exhibition in a museum. But if it's an exhibition in the museum, what does the museum learn from that? It's not only what the people will learn. And you can see that now. I'll show you some examples taken from museums of how this has influenced the practice of museums and science centers. This is the way that museums were organized, and sometimes are still organized. Very top down, very, from the museum to the public, show all the collection, and it is indeed the beneficiary, say, of this is the public, is not the museum. The curator has spent an enormous amount of time in creating that beautiful collection of cameras there or transportation means, but then his or her work is done the moment it's put on the museum. And nowadays, instead, you have museums. This is the Science Museum in London, which continuously question, well, why do we collect? Why do we think that piece is important? And as you see here, for instance, it's not anymore thematic. It's not, the gallery of airplanes. This is really all the innovations and the technique that has made the modern world from the beginning of last century to today. And there is a lot of listening that goes on in these galleries by the museum to understand how people make sense of this. What do they think when you put together, the first locomotive with the first airplanes with the latest jets and so on. And so the museum and the curators and the educators in the museum really start to learn themselves, and they learn how to communicate science from the visitors. So the important thing is really the museum starts to listen and implements that kind of reflexive practice which I described before. This is the usual way that natural history museums were exhibiting stuffed animals in behind glass like this. And nowadays, and this is a museum of natural history in Trento in Italy, is done like this. All the animals kind of float in the big atrium of the museum, and they are organized actually by the level where they live in the mountains. And people walk around, and there are exhibitions around the museum, but they always see the animals, because this is a museum of natural history. And even if there are exhibitions on, there is one, for instance, on how to do rescue things on the mountains and all the technology there. But it is about the mountains, and who lives in the mountains? They live there. So that is how, indeed, museums are changing their practice. And this is one of my favorite examples. This is the Natural History Museum in London. They did an exhibition called Sexual Nature a couple of years ago that was exploring sexuality in animals. Well, they have sex as well. And they commissioned some specific taxidermies of animals to show and for the exhibition. And it was great because also it was an exhibition for adults, and it was, natural history museums, usually they have stuffed animals and dinosaurs, favorites of the kids, and it's great. But the Natural History Museum was realizing, well, there are also a lot of adults without kids that come to the museum, and maybe they want to see something different than dinosaurs. And therefore they did this exhibition which explored indeed the sexuality in animals, and by that it allowed also people to reflect on their own sexuality. And it was indeed very, very provocative, but also very, very nice. And finally, another example, this is a example of a museum of anatomy. Again, all kind of stuff behind glasses. And this is the Deutsches Museum in Munich, in Germany, where actually the glass is very low, and what you see there is a laboratory of nanotechnology. Is the same laboratory that is available at the university. There are microscopes, electron microscopes, and all kind of instruments to do research on nanotechnology. And students do their PhD in this lab. It takes a bit longer than doing a PhD at the university because they are constantly talking with the public that ask them, well, what are you doing and what is it? And it's an incredible success now because the students, because they have to talk with the public and get their questions, they understand first of all, they understand much better what they do. Because if you have to explain it in very plain terms to an audience, is the best way really to study a matter. It's very easy to explain something in complicated terms. It's much more difficult to do it in simple terms. So that's one thing. But also they get a lot of really interesting questions that they never thought about. Because scientists sometimes, they are a bit like, like horses, they have the thing. They look in one direction. And this is a great way to broaden their view and therefore it's extremely successful. And even if it takes more time, there is a waiting list now of students that want to do the laboratory in the research there. So it is indeed a new way of doing science in the museum. And finally, there is a short video game, so maybe we can turn down the light. Thank you. Which comes from, again, from Dublin, and it's two artists. Actually, Dmitry Gelfand is from St. Petersburg, and Evelina comes from Belarus, but they live in Amsterdam, among other places. And they'll just explain a piece of art and science they did for the Science Gallery in Dublin.
By means of a white laser which traverses water in which electrolysis is taking place, where you can see water splitting up into its components of hydrogen and oxygen, all of a sudden this tremendous chromatic depth perception is created. Each and every microbubble of hydrogen behaves like a lens.
We wanted to create a very direct experience with hydrogen because it is such a fine element, so delicate, and you can see it in the behavior of the bubbles, and sometimes they are very, very fine and they come in these very perfect lines, and without the laser you just see them as dust, you will not see them as bubbles. When some air bubbles occasionally will rush through the aquarium, you can see how fine the behavior of hydrogen is comparing to the air bubbles. We also fancied this type of a galactic observatory where you can watch hydrogen clouds, and this is what happens in the universe all the time. The thing about voltage is quite an interesting question because the whole system can run on 1 volt. You need so little electricity to split water and to produce hydrogen, the most efficient fuel, and we didn't know that before we built this installation.
The most efficient atom in the cosmos, it's not a coincidence as to why it was the one that started it all.
So this was indeed a piece of so-called art and science where artists and scientists work together. And as you can see, it's from something so simple like this one, which was a system basically to split the water into hydrogen and oxygen. There are so many then conversations that can develop in terms of the efficiency of the fact that indeed why hydrogen is potentially a perfect source of energy and so on. So this is the kind of tools basically that museums and science centers and so can use to get conversations and to also to continuously understand and to create value out of that. It's very different showing just the phenomenon of electrolysis and say, okay, this is how it works, to having something like this that questions immediately. Hey, why do we have hydrogen as a source of energy? And then this can provide you, if not with the answer, with the thinking of why it happens. What we have to realize is that the way this approach works depends on something that is called the long tail, and basically says that if you use the kind of broadcast model, which is the one-way sending out, that touches a lot of people. You can reach, but there is limited interaction that happens there. And the smaller the amount of people, then more intense these conversations can happen. So the examples that I showed before, of course, these conversations are among small groups. Maybe there are many of these conversations, but the people who look at the students doing their PhD at the museum, those are conversations that happen among a small group of people, of course. It is not the big lecture with 3,000 people. And we have to understand how this is changing in order to make sure that all the activities that we develop are built for smaller groups where the interaction is much, much higher. This is basically the same phenomenon that happens online now, where you have a few people who contribute a lot. This is the way people, for instance, post pictures on the internet. A few people contribute a lot. Is the same as with Wikipedia, for instance. And many, many people contribute a little. What is important is that concepts as the average or the median do not mean anything anymore. The average experience, it doesn't mean anything, because if we take this chart here, indeed the number of pictures, for instance, saying that on average people post 26 pictures doesn't tell you absolutely anything about the dynamics of this. And the same is in the museums. There is no average visitor. Every visitor has a individual dynamic, and the challenge is really to understand that dynamic. So, going back a little bit on, so why to do all this participation and engagement and experiment with all these different formats? Well, there are three basically reasons why academics and practitioners and scientists believe that it's important to engage and to involve the public. One is called the normative view. Basically, it says it is the right thing to do because it is part of the democratic process to engage people in this. The other is an instrumental view. Says it is useful. You get results that are better because you have access to specific knowledge. It is a little bit like market research. Doing a survey before you launch a product will tell you if people will like it or not. So engaging people, for instance, in discussions on a new nuclear plant or a new traffic regulations will allow you to get a better understanding of what people think, and therefore and not only people, but also of the scientists or the industry and so on. But increasingly, there is a third view, which is called the substantive view, which says that by this engagement, you get results that are generally better. You get really outcomes that you would never be able to get from an institutional point of view. So going back, for instance, the example to do a new scheme for mobility in the city, the office or the university that deals with the problem will not get the same results as if they involve also the citizens and many other actors, because they get results which are better. And this is because indeed science is becoming so complex that only the scientist, only the technology point of view is not enough. This is, by the way, goes back to the concept of responsibility, and is the core of what now is at the basis, say, of the European Commission approach to science and research, which is called responsible research and innovation, which really tries to say, hey, research and innovation is really about envisioning a future and making sure that all the parties involved, meaning really everybody, is responsible for that, and also that the outcomes are sustainable, are accepted by society, and are also ethically sound. I'll show you a few examples of that. You know, in this slide here, there was this guy with a t-shirt, what if we could hack the brain? That comes from an event that's done every year called Hacking the Brain, where basically student makers, you know, the ones who are knowledgeable with technology and stuff like that, and computer programmers, get together for a couple of days to invent new ways to connect with a brain and see, you know, what kind of interfaces you can build. Well, now there are companies that sell this kind of devices that stimulate your brain with electricity, and it turns out that it has some beneficial effects. It can relax, or it can energize people. It is a completely unregulated, completely, you know, like the Wild West. Everything can happen. These devices are sold, but nobody really knows exactly if they are really good as they say they are. There are studies that show that they are beneficial for people with, for instance, epilepsy, but more and more kind of normal people without epilepsy are buying them to get stimulated. And this is a typical example where we really don't know where we are going with this science, and only by indeed this process of engagement and testing and having the hackers on the one side and having the industry on the other side, we can develop better science and innovation. And probably, you know, in a few years, instead of using our fingers to work with our phones and tablets, we'll use these devices. Is actually quite feasible. There are now tests that show how you can actually just, you know, with your brain command and steer and move some devices. So, but it is really a field where this responsibility is needed, because also we don't know if this stuff is dangerous. Actually, some people get hurt by this. So how do we deal with that? And whose responsibility is, you know, it's not only the scientists, it's not only the company producing this, it's also the public that accept this or not. So in that sense, indeed, responsibility is a shared thing. This is another beautiful example. It's a research project to use robots in healthcare. Now, there will be also here a short video. You know, there is a big problem in our society in the same, or problem. People are getting older, which is a great thing because we live longer and healthier. But it means also that people who live longer need also special care. And there will be more and more people living older. There will be less people in at the age where they can provide services. So there is a demand for new ways to provide healthcare to elderly people. So there is a group, this is in Amsterdam, which is looking at using robots in healthcare. And they tested this robot called Alice with some elderly people. Their background of the researchers is really in artificial intelligence. So they said, well, human care is the best care possible, so a robot should try to emulate that. And they built, you know, they wanted to try all kind of systems to make sure that the robot can understand language, can reason to some extent, can have indeed some kind of intelligence, can have moral judgments about what the elderly person would do. And then the interesting thing, so they made a movie. A documentary filmmaker contacted them to make a documentary about this test that they did with elderly people. And this is just the trailer of the movie.
In 2024 hebben wij 4 keer zoveel 80-jarigen als dat we nu hebben. 3/4 van de mensen van 80 heeft iets waardoor je zorg nodig hebt.
Hallo, ik ben Alice.
Kan je me goed verstaan?
Jazeker. U vertelde me over uw zoon, Jeroen.
Dat heb je goed onthouden, Alice.
Dat vond u leuk.
Grappig.
Hoe gaat het met u?
Ik ben er nog en ik probeer me nog te handhaven. Dat is alles.
De postcode is 1057 BA.
Dirk Anton.
Niet Dirk, maar Bernard.
Hè? Dit is mijn man en dat is Jeroen.
Iets hoger.
Nog hoger.
Knappe man. Zullen we even naar buiten gaan?
Ja, als je dat wil.
7. 8. Nog een paar keer.
Dit wordt uw nieuwe vriendin. Hoor je dat? Jij wordt mijn nieuwe vriendin.
Wat leuk. Voelt u zich wel eens eenzaam?
Jazeker, dat voel ik elke dag wel.
Oh, dat is jammer.
Dit is geen hulp, dit is dat zij nog eens helemaal bewust wordt van het feit dat ze zo eenzaam is.
Ja, ik heb vernomen dat het de toekomst zou worden in de zorg. Maar ik sta er nog wel heel sceptisch tegenover.
Maar hoe vindt u dat nou, zo'n robotje in huis?
Oh, heerlijk.
Hup, Holland, hup.
Yeah, so the movie actually is beautiful and has won a lot of awards, international awards for science communication. But the great thing is that after doing this test, the scientist wrote a beautiful article of 5 pages where basically they said, well, we were wrong with a lot of the assumptions, a lot of the thoughts that we put into this robot, because we were thinking of indeed making it intelligent and being able to have moral conversations and so and so. And actually what elderly people want is something very simple that can stay with them, that can listen for 15 times to the same story without being annoyed, who can tell them indeed to do the physical exercises. You know, older people usually are ashamed of their body, so they have difficulty actually to do those exercises or to dress in the presence of a human health provider. And they love the robot for that, because they are not ashamed of who they are. So there are all kind of different things that this test and using indeed the robot with people allowed the researchers to realize. And this, to me, is the value of science engagement, when not only the public realizes indeed what science is, but when scientists really understand what their responsibility is in doing what they do together with the public. And finally, there is one last thing to think about indeed what responsibility means. There are I'll tell you in a moment who that is. There are, of course, academic ways to think about what responsible research means, but there is a wonderful piece of research that shows that whatever the subject is, when you deal with the public about contemporary science and new technologies, people tend to react in 3 different ways. And people means everybody, from the scientists to the common citizens, in 3 different ways that overlap with each other. And one is the so-called the positivistic narrative, the story that science is good, we'll make progress, we'll live in a better society because science and technology will bring us further. The second one is a narrative of being careful what you wish for, and it comes back in many, many, many stories. I put actually also a Russian one there, which and it's basically the same story that comes back in many, many different ways. That is basically, don't go too far because then you will get burned. And it is indeed that kind of being careful to approach and to use science without indeed knowing what you do. And the third one is a modern narrative of social justice and injustice. Basically, it's a story that says that, well, yeah, technology is good, but only the rich people will get it, or only the rich countries, and poor people actually will get poorer, and rich people will get richer. And I want to leave you with this, because this is a very, very powerful way. Whenever you deal with new science, you will always find, indeed, these three narratives in the way people react. And if you know how people react, then it will be also easier to do whatever you need to do. And these, indeed, are things that are intertwined. They exist at the same time, of course. This little thing here is actually another example of art science. It's a sculpture done by an Australian artist that wants to challenge us to think about synthetic biology and what synthetic biology is basically using technology to create new forms of life. And this little creature is of course a sort of a pig with human elements, and it challenges us to feel, but she's so sweet in a way, it's scary, but it's also very, very sweet, and it challenges us to think about the empathy that we should never forget when we deal with such complex issues like creating new forms of life. And also it's quite interesting because we use actually pigs to create, for instance, to make valves for our hearts. So there are people actually that live because of the pigs, and this is kind of reversed in sense of a pig getting some kind of human aspects. And this was indeed a very, very strong conversational piece that got a lot of people thinking and dealing with the issue of synthetic biology. So that is basically almost the end, because the real end is something that we won't do now, but you will do later, and it's called Play Decide, and is a simple way to do with your hands what we have been talking so far in more or less abstract terms. And it's a game, it's a playful thing that gets people to talk about topics that are very controversial. So I brought some of these kits, and you will do that later in the course. And it's a way to use to structure basically a conversation in small groups of people, 6-7 people. I can show you just very quickly how it works, but I'll tell Dimitri, give the instructions so you can tell people. It uses cards to stimulate people to discuss, and there are different kinds of cards. There are stories that very short that tells a story about the subject, and subjects are, for instance, nanotechnology, genetic tests, the use of animals in research, and stem cells, all kind of controversial topics. And the great thing is that you don't have to know absolutely anything to discuss about these topics, because indeed some information comes from the cards, then there are cards with facts, so you get real facts about what is happening today in research with that. There are cards with issues, so what are the problems, and you collect some of these cards, and then you start to discuss. You organize them on your placemat. You start to discuss with other people, and you realize that after 15-20 minutes, even if you come from very different points of view and perspectives, you can reach a common ground, a common understanding of the subject, which we use in the game to vote on how this issue should be regulated, because in the end we are all citizens living in society and we kind of like to regulate things. So at the end you can vote on how society should regulate this issue. And the purpose of this is to do exactly what we've been talking so far. It is really to get into conversations, in daring to talk about complicated subjects, and to realize that whatever your background and whatever your point of view, you have something to contribute to this subject. So that's the end of my talk. Thank you very much.
So we still have time for questions. Anybody? I have a question first. The play side, well, I know a little bit about the game and I played it actually.
Yeah.
Is there any like upstream engagement there? I mean, are the results of the game taken into account later on by policymakers, for instance?
Yeah.
Is there any kind of statistics?
Yes. Well, it can be done. As usual, with all kind of engagement activities, it's very important to say beforehand why you do this. So in the case of Decide, if it has been used to do real policy making. For instance, it has been used in all European countries on the subject of rare diseases, genetic diseases that are very rare. Very complicated matter because there are industrial interests, medical interests, and therefore it's important to regulate the matter. And the European Association of the Patients of Rare Diseases used this site to organize about 400 debates all over Europe to get the point of view of the patients, the doctors, the insurance companies, and pharmaceutical companies together in order to understand how to make better policy. And they created this policy and they gave it to the European Parliament. So it is done like this.
And the Parliament?
Well, the Parliament, that's I don't know what they did, but it is for us it's important that it's used as a sort of lobbying instrument by the association. Then indeed it becomes part of the policy-making activities. It has also been used by a worldwide cooperation of science centers on the issue of climate change, for instance. Again, most of these activities then end up being proposals that then the policymakers may or may not consider. It is very, very, very difficult to get like the approval of the policymakers to act on this kind of results before they see them. So it's but we're getting there. There are signs that is also being done.
Questions, anybody? Well, another question for me then. There are, in the recent history of public engagement, there are two cases that I think are in some ways opposed to each other. It's nanotechnology and GMO. Could you comment on that? I mean, in one case, apparently it failed. I mean, the public engagement, while in the other, it succeeded. I mean, nanotech is not as well prejudiced, not as looked down as GMO for some reason.
Yeah. So indeed, these are very, very good case studies. Well, the public engagement with GMO. Well, it failed in the UK because the UK made actually a big project on engaging the public on genetic food and genetic manipulation. It failed basically because it was not very clear from the beginning what they wanted to do. It seems like it was a way to get people's opinion / getting people approval of something that was already done. And you can't cheat the public. You always have to be very respectful of the public, because otherwise they will not trust you. So it failed because there was a lack of trust by the public. And also because maybe it's also a very much more complex attitude of European people in regards to food, for instance, than in the United States, where GMO is accepted without too many problems, and in Europe there is some kind of resistance to that. nanotechnology, I'm not sure if it succeeded. Nanotechnologies, they don't talk about nanotechnology a lot anymore. You know, compared to years ago, when there was really a lot of initiatives and a lot of talking about and exhibitions and all kind of public engagement about nanotechnology. Nowadays, there is.
But it's also accepted in the
you may wonder why. Maybe because indeed it's not talked a lot, but also maybe because it is. I guess because it's a technology that is yet less related to actually to human health. You know, food is something that we are confronted every day. So whatever happens to food, red alert. You know, whereas nanotechnology is there is of course a component that deals with health, but there are also a lot of applications that aspect are not so critical. And therefore, probably there is more acceptance because once you kind of sort out the difficulties and the risks related to health, it's a totally different kind of engagement. You know, now there are clothes using nanofibers, for instance, that are very useful and very practical, and people have no problem in buying them. I guess that is, but there are still. I think we are. I think it's too soon to say that nanotechnologies are accepted. However, because.
No, right. Just from what I know, the debate was started earlier than in case of GMO.
Definitely, yes, yeah. It is also a good example of, well, starting indeed. Certainly, the discussion of nanotechnology started way before the products. Exactly.
That's what matters.
That is definitely very. It brought positive results in that sense. Definitely.
All right.
Yeah.
So last chance to ask a question to Andrea, because you won't get this chance because he's leaving tomorrow. No.
Well, if you get any questions later, you know, submit it through Dimitri. I'll be happy to answer that.
Thank you again, Andrea.
Okay. Thank you.